Have you ever wondered why objects that are very close together in a vacuum appear to mysteriously attract each other? It's as if they're under a spell, drawn to each other by an unseen force. This puzzling attraction is not a work of magic, but a fascinating quantum mechanical phenomenon known as the Casimir effect. Imagine two ships in a sea filled with waves. If the waves between the ships are smaller than those outside, the ships will get pushed together. Now let's take this analogy and dive into the quantum world. Picture the sea as the vast field of quantum particles. These particles, like waves, are always in motion, constantly appearing and disappearing, even in a vacuum. This is the sea where our quantum ships or objects find themselves. Next, consider the two ships as two objects in this quantum sea. When these objects are close enough, something interesting happens. The quantum particles or waves between the objects can only fit if they are shorter in wavelength or smaller. Meanwhile, outside of the objects, the waves can be of any size. This difference in wave sizes creates a pressure difference, much like in our ship analogy. There are more larger waves pushing from outside than smaller waves pushing from inside. This imbalance in pressure forces the two objects or ships to move towards each other. This is the Casimir effect in action, quantum mechanics playing out in the vacuum of space, making objects move without any apparent force acting on them. In essence, the Casimir effect is a consequence of quantum mechanics allowing energy to exist in empty space. The Casimir effect is more than just an odd quirk of quantum mechanics. This phenomenon, where virtual particles in a vacuum exert a mysterious force on nearby objects, has profound implications. In the field of nanotechnology, it could be key to developing minuscule machines. In fundamental physics, it continues to challenge our understanding of the universe. So next time you encounter two objects mysteriously attracting each other in a vacuum, remember, it's not magic. It's the Casimir effect.